Expanded octets. So if you look at your periodic table, there are some atoms that can form expanded octets and some atoms that cannot. The atoms that cannot are in this 2p region of the periodic table. But once you get to the 3p region and anything below it, you can form an expanded octet. Sulfur is in that area. Chlorine and phosphorus are three of the atoms that we will see the most forming expanded octets. But it can also go down here. I think we'll see xenon forming an expanded octet in one of the Lewis structures that we will make this week. Anyway, so first off is knowing who can form expanded octets. And that's all of these elements in the 3p region and below. Okay.
So, Professor, is it right to say the 4s and all the S block doesn't form an expanded octet, or the Z block, just the P block?
It is just the P block, and that's because we're only talking about the non-metals forming covalent bonds. Okay.
I see.
Yeah, so once you get over to the other side of the periodic table, they're always going to form ionic bonds, at least in this course. And I would say you have to get very high in chemistry before you start talking about other types of bonding. Well, I guess not that high, but it's a little ways off yet. And since this is potentially your only chemistry course, we won't deal with that. All you need to know is that the P blocks can do it, and the non-metals there. Yeah. Okay. So then maybe your next question is, well, why can they do it? And we have not talked about this yet, at least I don't know. So we're supposed to talk about it next week. But it turns out, well, in full detail anyway, but so if we were to do the Lewis structure, or sorry, the electron configuration for sulfur, the electron configuration would go like this: neon, noble gas core, and then 3s2, 3p4, okay, and it turns out that we have an unfilled 3D sublevel. And it turns out then that the reason we have the octet rule is typically because you fill up the valence electrons, S's and P's, and if you fill the 3p with 6, that's 8 valence electrons. That's the octet rule done. The octet rule is there because octets of electrons tend to be stable, and that's why the noble gases tend to be stable. But it turns out that if a molecule has a bunch of formal charge in it, then it can also be stable to put extra electrons in the 3D sublevel. So the unfilled 3D sublevel can hold the electrons in an expanded octet. Okay? And what we get, and so, okay, so 3D, our picture of an atom, if we look just at the n equals 3 sublevel, is that for the n equals 3 sublevel, we've got 3s, we've got orbitals that we call the 3p's, and then we've got 3d's. And the 3d's have more or less 4 parts. And our idea about this is that in the n equals 3, and let me get on page here, we are stuffing electrons into the same volume, the same sphere of space. And it will turn out that you can stuff electrons into 3D. And that's where the electrons go. If you come back to the periodic table here and you look at the 2p area, there is no 2p or 2d, d as in dog, sublevel. And so these elements cannot have expanded octets. Because it's like another way of putting electrons into the same space. I don't know if that's a great answer, but that's certainly an answer that works for this course. And I'm happy to answer questions about that. But that's sort of like if we peel away the chemistry onion, so elements in the 3p area or non-metals in the 3p area and below can have expanded octets. Why? Because they place those electrons in the D sublevel, and those electrons we will see are then hybridized, and we'll talk about hybridization, I think, in next week's lecture outline. Anyway, I hope that's a little bit, Daryl. I don't know if you have any questions or anybody else does.
I get it now, Professor. Thank you.
Sure. Okay.
Oh, but I still don't get why you had to minimize the question. The question didn't ask us to do that, did it? Or are we supposed to do that for every Lewis structure that we draw out?
Yeah, so the question didn't say that, and that was because it was the first question on the homework. And you don't have to do that for CH2O. But starting with the second question, and I didn't want to do your homework for you. Like CH2O is much simpler than this. But starting with the second question, and in all future homework questions, you will always do this.
I see.
Yeah.
But Professor,
yeah,
looking at it, you can tell that sulfur is +2, and you have 2 oxygens which are -1H. You can see that the charges are going to cancel out. Do you have to draw it showing the FC?
Okay. So on the homework, all I need to see is your final answer, but this is the final correct answer. And what I would suggest is that your process should basically always, this should always be your process. Whether you write it all down or not is up to you. But so this answer here, just the red part where everybody has octets, is not the answer for this course.
I see.
Some very beginning chemistry courses have this be your final answer because they don't talk about formal charge and expanded octets. And so if you look on the internet and you type in SO3, you may get both of these answers. And you'll have to choose. And again, I don't care if you look on the internet for help, but when you get to the exam, know this process. So, does that answer your question, Daryl?
Yes, Professor. Thank you.
Yeah. So, yeah, and what's weird is as much as we like math, there's very little math for the next chapter well, I don't know, some topics have almost no math and some topics have addition and subtraction, and that's about it. Maybe a little multiplication. But when you do this, you will see that the answer for the one for the first homework question is much simpler than this. Anyway, but I didn't want to do your homework, so I chose another example that would demonstrate the whole process. And I guess the last thing I'll say is even for CH2O, when you make the Lewis structure, you should think about formal charge. It will turn out that all the formal charges are zeros when you have the Lewis structure.